All right. So let's get started without wasting any time. So this is the very first session, live session of competitive programming course, right? So why did I get started with the live session? Because I have been asked so many times, so many questions that I cannot actually reply to every single person, right? And I believe those are important questions. That's why I thought, okay, even though I have every single course available, right, for competitive programming, it doesn't exist in certain, the order. You don't know which order you should cover different algorithms, right? For example, you are going through number theory and bit manipulation. How do you go ahead with those, right? You have like 10 different courses, so which one you should get started with, right? And after that, what you should cover, things like that. We haven't covered those yet. So I thought, okay, it's a good idea. Let's get ahead and show you the guidance, give you a guidance that where you should start, where you should head next, how you get started, how you should practice, and how you should proceed with your learn. So that's why in this session, in these live session, I'll do that exactly. Right? I'll try to guide you all. So this is the agenda that we are going to cover here. So we'll get started with the very famous question that I've received so many times, how to get started with complete programming. After that, we'll learn, since this is a very basic session, so we'll learn basics of time complexity, what is brute force and what is algorithmic or optimized solution with an example, of course. Then we'll learn the primality test from number theory. And then at the end, I'll give you some exercises based on the current session that you can go ahead and practice yourself. Right? So let's get started. So first thing first, how to get started with competitive programming? So the question is, what is first? Let's define what is competitive programming. So competitive programming is a competition, as the name suggests. It's a competition where multiple programmers from many countries participate in, and then they solve questions, right? And you are given multiple questions to solve and a specific time limit. For example, 2 hours or 3 hours time limit. So you have to solve those questions in the given time limit. All right. So each question of course have certain score along with it, and based on that you get score and your rank. Right. So that is competitive programming. So the questions that are designed that can be solved using data structure, specific data structure or algorithm or specific techniques. Right. That's why when you are asked how to get started with competitive programming, there is something that you need to learn before you start participating in contests. It is not bad idea to just go ahead and start participating in contests, but it is important that you have knowledge of certain data structure and algorithm, right? So when you're going to get started with competitive programming, it is advised that you learn data structure and algorithm because most of the problems will be solved using those. So when you are getting started with competitive programming, learn data structure and algorithms, right? And in the background, and also keep participating in contests, even if you are scoring zero, doesn't matter, right? So learn data structure, learn algorithm, and just because you have the knowledge of data structure and algorithm doesn't mean you will be able to solve all the problems based on those data structure and algorithm that you have just studied. So what you need to do, you need to practice problems. This is like the second step. So let's say you have learned binary search recently, right? Now you're going to solve a problem. You got a question in competitive programming contest that you were not able to solve. Once the contest is over, you are going through its editorial and you see that this problem can be solved using binary search. But even though you had the knowledge of binary search, you were not able to solve this problem using it. So it is very likely that this happens. All right. So why this happens? Because same algorithm or data structure can be used in different ways, in different scenarios, in different problems to solve it. All right. So it is important that once you acquire the knowledge of certain DSA, you go ahead and practice problems related to that. This way, you will not just have the knowledge, but you will have the knowledge of how to implement those DSA to solve certain type of problems. Right. So just to summarize, competitive programming is all about data structure and algorithms. And once you acquire knowledge of any new DSA that you have just finished, make sure that you practice at least medium level problems using that algorithm or data structure. This will give you a huge confidence boost, and also give you an idea how this is implemented to solve problems. All right. Now, since we have to cover a lot of things, this is where I will stop to explain this, how to get started with competitive programming. And again, one more thing, you should be very persistent with your goal, right? You can't just lose focus or your confidence that I have been learning DFA for past 2 months, and even though my rankings are not improving, it is possible, but just keep in mind that you just need a little more practice. You just can't leave it in at the beginning, right? You have to spend a lot of time. People spend years learning this and implementing, right? So just don't let that negative energy get near you. Just keep on learning and keep on practicing, and I'm 100% sure that your ratings or rankings will improve. All right. Oh, let's move on to the next session. Okay, so when you are participating in competitive programming, we'll be learning, you will be utilizing time complexities a lot. Okay, now since this is introductory lecture, I won't be going into so much details of it, right? But I'll explain how time complexity can be utilized in competitive programming. So anyone has any idea what is time complexity? Anyone in the comment section? I'm waiting just for a minute for any response. Otherwise, we'll move on, of course. Anyone has any idea what is time complexity? You might have seen something like this in competitive programming problem or in the editorial. So, the time complexity is a way of measuring the speed of your algorithm. Okay, this is one way to define it. Yeah, I mean, I've got one response for time complexity, the worst case and best case. Yeah, these are different types of time complexities that you measure. So time complexity, you can have worst case, average case, and best case time complexity. Since we are talking about competitive programming, we'll only worry about the worst case. Why? Because see, when you write a solution to certain problem in competitive programming, you are given a limit, time limit, that your program should be able to submit the solution. Your program should be able to print the solution in 1 second or 2 seconds. This is a time limit on your solution. All right. So if you can, as you can, your solution is able to run in the worst case scenario, it will of course cover the average and base case also. So in competitive programming, we only worry about the worst case. So Vishal has given some responses. So yeah, these are the time complexities: best case, average case, and worst case. So we'll only think about the worst case time complexity, which is big O notation, which is represented using big O notation. You see O here. This is big O, small o, and big O, yeah, capital O, right? So this is called big O notation. So you might have seen something like expected time complexity is ON of the solution. Yeah, you might have seen solution time complexity is n square, right? The worst case time complexity. So what does it indicate? It indicates that if input size is n is the number of elements in your input. For example, number of integers you have to process and print their sum, right? So if n, the number of input is n, then your solution makes these many operations, right? Your solution does these many operations. This is all approximately, right? So your solution approximately does these many operations, right? Or if we talk about the second solution, this, it makes n square number of operations. All right. And when you are working with time complexity, it's important for you to understand that the online judges that you use, either code forces or spodge, you can take their average speed to be somewhere around 10 to the power 8 number of operations per second. I have been using this rough roughly this speed of compilers for Spoj or Codeforces or any other compiler, and till now I've found this to be quite accurate. Okay, so you can assume that the average, or you can assume the compiler speed is roughly around 10 per 8 number of operations per second. Okay, this is a very rough estimation. So let's say uh, for n is equals to 10 raised to power 5, we for a particular solution we have two algorithms, one that runs in big of n time and another that runs in n square time. So you see, the big O time complexity tells you the number of operations your solution does, right? Roughly, it's all roughly, all right? So first solution will do these many operations, 10 per 10 number of operations, right? Because n is 10 per 5, n square is 10 per 10. So this algorithm will do these many operations, that is 10 per 10 number of operations. Compiler speed is roughly 10 per 8 operation per second. So total number of seconds or total time will be 10 power 10 divided by 10 power 8, which is compiler speed, that is 100 seconds. So an n square solution, if n is equals to 10 power 5, will do these many operations, and how much time will it take? 100 seconds. So if time limit was 1 second for the solution, of course this will result in time limit exceeded or TLE, right? Now the other solution which works in big of n time, right? The worst case big of n, so it will do 10 power 5 number of operations. So these many operations are there. Compiler speed stands for 8. So total number of time, I mean total time taken would be 0.001 second. Again, all are rough estimation. It can be 0.00125 or 18, doesn't matter, but roughly 0.001, right? So this way you will be able to already estimate whether your solution, if you have the idea of your solution's time complexity, you will be able to estimate whether your solution will get TLE or not. Okay, so this is how we use time complexity in competitive program. We generally talk about only worst case time complexity, and then we see for input, if n is equals to this, will my solution pass or get TLE, right? So if time limit was 1 second, n square solution will not pass for n is equals to 10 power 5, but linear solution, that is big of n solution, will pass, right? Because it does the work in less than a second. So this way we utilize time complexity to estimate whether we'll get TLE or. All right. Since I'm not covering time complexities in detail, I'm highly recommending you to just Google time complexity and how to calculate time complexity of a solution and just learn it, right? So for a given piece of code, you should be able to evaluate its time complexity. Now, time complexity evaluation is a bit hard for recursive solutions, so just leave those since you might be just getting started with the time complexities. So just leave the time complexity calculation of recursive solution. Beside that, other calculating time complexity of other solution is very easy. Okay, so just make it a note that you have to calculate, you have to learn how to find out the time complexity of the solution, right? Fair. This is about time complexity and how we use it in competitive programming. Next thing, a brute force solution and algorithmic solution. We are going to discuss this. So again, I'll be waiting 1 minute. Anyone has any idea what is brute force solution? This is important. I'll wait for 1 second. Oh, sorry, 1 minute. Okay. Just any idea what is brute force solution? Yeah, I've got one response from Vishal that it is worst case solution, which is not completely wrong, right? It is quite. I mean, it is not completely wrong, and it is to a certain degree, yes, it is correct. So, what is brute force solution? the solution which you just thought of, and without optimizing it, you just implemented it without any optimization. For example, let's say I'm giving you an example of finding, I'll give you an n, let's say n is equals to 10, and you have to find sum of all integers in the range 1 to n, right? So brute force solution can be, you are running a for loop from 1 to n and adding all integer I, right? So this way you will get sum of all integers in range 1 to n. So this is brute force solution. Why? Because you didn't optimize it. You know how to find it and you implemented it as it is without optimization. If you think of the optimization, what you can do, instead of just running a loop from 1 to n and adding all integer I to get the sum in the range 1 to n, you already know sum of all integer till n is n into n plus 1 divided by 2. Instead of running a loop, you will simply evaluate the sum by evaluating the formula n into n plus 1 divided by 2, and that's it, done. No need of for loop, right? That is an optimized solution. So yeah, I mean, response of Vishal is quite correct. It's kind of a worst solution we can say, if we compare it with the optimized solution. So let's understand the brute force and algorithmic or optimized solution using this example. So we have to find, uh, you are given n integers, right? And after that you are given q queries. You have to perform on those n integers, and the queries are of the form lnr, and you have to find the sum of the integers in that range, right? N can be as large as 10 to the power 5. So as large as 10 to the power 5 number of integers can be there, and number of queries can be again as large as 10 to the power 5. So let's say these are the queries, and let's say 10 integers are given to you. This is the input array, right? And these are the query. So if you evaluate sum of all integer in range 1 to 5, if you add all the 5 integers, the sum will be 13, right? 2, 1, 0, 6, and 4. Total sum is going to be 13. If we take range sum 4 to 6, that means 4th, 5th, and 6th integer, their sum is 12. And if we take the sum of this range 8 to 8, that means 8th element, which is 5. So we'll get 5. So basically, you have to find the sum in this range LNR, right, for each query and print it. As simple as that. This is the problem statement. If you write the brute force solution of it, which is the kind of worst solution of it, what you can do, you know how to find sum. You can just go through all of the indices and take their sum and print it, right? So what you'll do, you'll run a for loop. Brute force solution would be something like this. Sum is equals to 0, and you can run a loop in range L to R. So I is equals to L, I less than equals to R, I plus plus. Each time just add the ith integer into the sum. What is AR? AR is the name of this array. I forgot to add the name here. So AR is this array. So each, just go through the whole range. Initialize sum is 0, go through the whole range. Each time in sum just add the ith integer. As simple as that. And this way you will get the whole sum. Right? So this is the brute force solution. We are not optimizing anything. We know how to calculate it. We are just doing as it is. We are coding as it is without any optimization. Right? And if you optimize, if we see the worst case for this algorithm, right, that we have written, for each query, in worst case, it will take linear time. We go of n time, right? Why? In the worst case, range can be as large as 1 to n, right? In that case, you have to go through the whole array of n integers. That's why you need to perform exactly n number of, roughly around n number of operations, right? Since there are q queries, in worst case, each query can be 1n, 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 right? So q queries n number of, and each query answering takes n number of operations. So total number of operations will be qn, q times n. So that will be your time complexity for brute force solution, right? And in the worst case, n is 10 to the power 5, q is 10 to the power 5. So n times q is 10 to the power 10. Compiler speed is roughly 10 to the power 8 per second. So 100 seconds this solution will take, right? If the if the time limit was 1 second or 2 second, this solution will get TN. All right, this is brute force solution. So we just know how to do it. We just implement it as it is without optimizing it. Right. The other solution, the optimized one, uses prefix sums, as Vishal in the comment section has already written. It can use prefix sums to evaluate a range sum in constant time. Constant time means number of operation will remain same. Let's say key, I'll explain in a moment. Number of operation doesn't depend on array size. Okay. For example, now again everything is same. If we see here, we have one more array. So this is an extra array that we evaluate. All right. So what does it show? It is a prefix sums array. You can learn more about it. I have already explained it in the in basics algorithm course. All right. I'll put the link of that course in the description of this lecture. All right. So you can prepare a prefix sums array. It is very simple. What it is? So see, if you want to know the ith element, so AR of I will tell you the ith element, right? Prefix in prefix array, ith element doesn't actually indicate the ith. Sorry, in prefix array, ith index doesn't actually represent the ith element, but some till index I. So, for example, if you look at this 9, in 9 is sum of all the integers till this point, right? So if you add all of these, it is 9. If you add all of these, this is 13, right? So pre of I actually represents sum of all integers in the range 1 to I. All right. So that's why we have 2, then 3, 0, and then sum till here is 9, sum till here is 13, sum till here is 15, so on and so forth. This way you can prepare the prefix sum. Run a loop from 2 till n on one based index system. Run a loop from 2 till n, and prefix of I is equals to sum of the current element and prefix of I minus 1, right? So basically, if you want to find out what will be the total sum till this point, you can take total sum till this point, which is prefix of I minus 1, right? Which is 9. Just add the current element, right? So this way you can prepare the prefix sum array. And once you have prefix sums array and you want to find out sum in a certain range, you can do prefix. Sum will be prefix of R minus prefix of L minus 1. As simple as that. Right? For example, you wanted to find the sum for the second query. Sorry. For the second query, sum will be in the range 4 to 6. That means sum of all these three elements. If you take pre of 6, which is 15, right, which is R, pre of R, which is 15, right, but it contains sum of all the element from 1 till 6th position. I don't want all, I want only from 4. So just take sum till 6 or sum of all integers from position 1 till 6, which is 15, and subtract those which you don't want. You don't want these. You want from 4 to 6, you don't want 1, 2, and 3, right? So you can subtract prefix of 3, right? So basically prefix of R minus prefix of L minus 1. I'm going very fast here because everything I have explained in the different lecture where I was explaining prefix sums and how to answer range query using prefix sums, right? In the basics algorithm course, I'll put the link of that course here. Of course, that is also available on my channel, so you don't need to worry to pay or do anything. Everything is available on the channel. Right? So using prefix sum, you can actually evaluate the sum by performing only one subtraction, which is constant operation, right? No matter what is the size of the array, it how you are calculating the sum doesn't depend on that. Only prefix of R minus prefix of L minus 1. Yeah, only this part which you do exactly once. Prefix sum array you need to prepare one time. After that, for each query you can only utilize it, right? So if you see the time complexity here, for preparing prefix array you are running a loop from 1 till n or 2 till n. It's like n number of operations, and then for each query you are answering it in constant time. Constant time means this. When you write big of 1, it doesn't mean then that operation number of operations are exactly one, it means constant. Okay, big of one means constant. Here we are having only one operation. It might have been two and three operations. All of those are constant, right? They doesn't depend on n. Right? So number of operations are constant. Just to understand, you can understand it as one also. So for each query, we are performing constant number of operations. So q times one will be q itself. So q queries will be answered in big of q time. Before that, we have to prepare the prefix array. For that, you are running a loop till n. That means big of n time that is also taken. Right. So total time will be 10 power 5 plus 10 power 5 divided by 10 power 8. That means 2 times 10 power 5 divided by 10 power 8, roughly 0.002 seconds. So this way, using the prefix sums, if you would answer the queries, it is not going to take more than these. It is not going to take more than this time. Right? Again, all of this is approximate calculation. It is not to be understood exactly the exact value, right? So the thing is that you will be able to solve the problem in less than 1 second, and hence this solution will pass if the time complexity was if the time limit was 1 second, right? So again, this prefix sums I have explained in much greater detail uh, in another course. I'll be putting the link of that course in the description so you can go through that. All right. So yeah, this is an algorithmic solution or optimized one. Yeah, Rahul has also responded. What is time complex? It is time required to run the program. All right. Yeah, now we are on primality test. Okay, so we'll be again discussing both the solution, brute force ones, and the optimized solution. Now, primality test is an important concept. In many number theoretic algorithms, you will find this exact solution that we will be discussing here. That solution will be used in multiple different algorithms. So this is very important to understand. Okay, we'll be learning both the brute force and the optimized one, right? So problem is very simple. You are given n and you have to find whether n is prime or not. So when n is equals to 7, of course it's a prime number, so we are printing true. When n is equals to 15, we are printing false because 15 is not a prime number. It has a divisor 3 and 5, and 2 is true because 2 is the smallest prime number, right? So now since some people are active in the comment section, so can you tell me, for brute force, we have to run a for loop in what range? Correct? And I'm giving you 1 minute. So for brute force solution, in what range we are going to run a for loop to test whether n is prime or not? As again, yeah, we have got a response. Yes, we need to run a for loop in range 2 to n minus 1. Why is that so? See, if you see the observation, if n is not a prime number, then it must have a divisor other than 1 and n. Right? Each number, of course. Yeah, we have got responses from Vishal and Avinash that we'll have to run a loop in range 2 to n minus 1, which is absolutely true. Why is that so? Because of this observation. For each number, of course, 1 and n are its divisors. For example, even 15, 1 and 15 are already its divisors, so we don't count them. Beside these two, if you find any divisor in the range 2 to n minus 1, that means it is not a prime number. And if you are not able to find any divisor in range 2 to n minus 1, then it's a prime number. Keeping that observation in mind, we can exactly implement the same thing using a for loop, right? So you have a flag, initialize it with true. True means that n is a prime number. So we are starting it from here. So n is a prime number. Then what you can do, run a loop in the range 2 till n minus 1. right? And if n is divisible by I, that means we have found a divisor in range this, and if we find a divisor, it is not a prime number. So flag will set to false and stop, come out of this for loop. So we'll break it, right? Otherwise, if we don't find any divisor, this piece of code will never be executed and hence flag will be true. So you can print true, right? So this way you will be able to find whether the given number is prime or not. So if we see the time complexity of it, it is linear, big of n, right? Because we are running a loop from 1 till n minus 1. Sorry, 2 till n minus 1. You can say it is n minus 2, big of n minus 2. But again, uh, time complexity is when you compute and you have constants in there. For example, big of n minus 2, by rule, you drop out all of the constants, right? So from n minus 2 will be dropped out and you will be left with big of n. So time complexity is big of n. So since it is linear time complexity and we already know what is the roughly speed of compiler, which stands for 8 number of operations per second. So if n is equals to, let's say, 10 to the power 9, how many seconds will this solution take to find whether n is prime or not? If n is 10 to the power 9, how many seconds will the compiler take to tell whether n is prime or not using this solution? Any idea? Anyone in the comment section? Yeah, I've got some responses. Yeah, it's going to take 10 seconds. Absolutely right. Because n is 10 to the power 9 and compiler speed is roughly 10 to the power 8. So 10 to the power 9 divided by 10 to the power 8 is roughly 10 seconds. So this will take 10 seconds. Right. Let's have a look at a better solution, an optimized solution. So that optimized solution is based on this observation. So this observation is that for each number n, its divisor appear in pairs. All right, the pair of d and n by d. So if uh, d and n by d are their divisor pairs. All right. So the property or the observation is, first of all, let's have a look at divisor pair of 30, then we'll talk about this line. All right. So if you see, the divisor pairs of 30 are 130, 215, 1 and 30, 215, 310, and 56. Why are these pairs? See, if d is the divisor, the other member of the pair will be n by d. So if 1 is the divisor, its another member of this pair will be 30 by 1, which is 30. 2 is the divisor, 30 by 2, which is 15. 3 is the divisor, 30 by 3, which is 10. 5 the divisor, uh, 35 by, which is 6, right? You can say that 6 is also a divisor, but that pair you have already here, right? So these are the divisor pairs. So if you see, the observation is that in the divisor pair, if one of the divisor is less than square root of n, I forgot to add r here, sorry for that. Okay, so by the observation we have this, if one of the divisor is less than square root of n, another one will be greater than square root of n, right? Both can't be less than square root of n or greater than square root of n. Why is that so? Let's say both of them are greater than square root of n, right? So let's say a and b are divisor pair, right? And both of them are greater than square root of n. If a is greater than square root of n, b is greater than square root of n, their product is going to be greater than n. My bad. Let me try again. If a and b both are elements of divisor pair of n, and a is greater than square root of n and b is also greater than square root of n, then their product will be greater than n, which is not possible. It should be equal to n, right? So this way you can actually prove that in divisor pair, one will be less than square root of n, another one will be greater than square root of n, right? This is true for each divisor pair. There is one special case where n is perfect square. In that case, you will find one pair where both elements are equal. For example, for 16, one of the divisor pair will be 4 4, right? Re- Except that for each divisor pair, one divisor is less than square root of n, another one is greater than square root. So how can we utilize this knowledge to optimize the solution? I have already got some of the answers in the chat section. See, Complex has replied that we can go from 2 till square root of n, right? We can directly go from 1 till square root of n only. We don't have to go till n minus 1, right? Why is that so? See, since for each divisor pair, it's one of the factor, see, one of the factor is less than square root of n, right? So for each divisor pair, if you are able to find one element, you will be able to find another one also, right? If I know that 2 is the divisor, then 30 by 2 is also a divisor, right? And only these pairs will be there. For each divisor, half of them appear before square root of n, half of them appear after them, right? And they form a pair. So if you find no divisor before square root of n, there won't be any divisor after square root of n, right? So I don't have to go beyond square root of n. I can only run a loop till square root of n. All right. So that's why an optimized solution will be to go till square root of n only. So if you see, I'm starting from 2, and instead of going I less than n, I'm going I into I is less than equals to n. That means I is less than or equal to square root of n, right? So that is the only difference in the previous algorithm and this algorithm. And now this for loop runs till square root of n only. So now time complexity of this solution is big of square root of n, right? So if n is less than 10, let's say 10 to the power 10, right? So how much time will it take? Can anyone guess in the comment section? If n is 10 to the power 10, this solution, which is having time complexity square root of n, how much time for it? How much time will the compiler take using this algorithm? If n is 10 to the power 10. Yeah, I've got a response in the comment section. Yeah, correct. It will take 0.001 second. Yeah, total number of operation will be roughly 10 per square root of 10 per 10, which is 10 per 5, divided by 10 per 8, which is compiler speed. So the time taken will be 0.001 second, which is absolutely right. Yeah. So you see, if we have used the previous algorithm, it would have taken 100 seconds. But using this algorithm, we are only taking 0.001 second. All right. So yeah, this is one of the optimized way you can find whether n is prime number or not. Okay, there are different ways also which are a bit complex than this. We'll learn those in next lecture. All right. So and there is also of course C algorithm that helps you find prime numbers in range, right? We those algorithms we'll be learning in next lecture. Till this point, whatever we have covered, I hope you have got the idea how it works. And since it was very simple, most of you have already the working idea of these algorithms, right? So finally, here are some of the practice problems from you for you. Static range sum from CSCS, range sum query mutable from lead code, problem code 303, and counting devices from CSCS. So these are three practice problems that you can try to solve, right? So yeah, we are able to uh, you know complete the session. We are able to complete the session in almost 45 minutes. So since we have some time left, okay, let's wait for 5 minutes. If any of you have any question, you can post it down here. Otherwise, of course, in the next session, in the next live session, we are going to cover the next concept that we should learn in competitive programming. Okay, so if again, I'll wait for 5 minutes. If you have any question, you can post it down in the comment section. I'll answer that. Right? We're waiting for 5 minutes. Then we can close this session. So if you have any query, you can just post down the comment section, and I'll try to answer it to the best of my abilities. Okay, so we have two questions. Let's have a look at that. Sir, I'm a newbie and following your number theory playlist. Although I'm placed inside this company, I'm learning CPU so that I can get to Google like you. Yeah, that is Vishal, and that is, I should say, a very good goal that you are learning number theory. You're going through number theory and you are learning CP so that you can get placed in Google. Not just Google, I would say, see, uh, any company that pays well. That is my motto. So if any other company pays more than Google, I mean, that's how that's what I think, right? I work for, of course, money so that I can provide to my family. So if anyone pays more than that, you should go there, right? And one important thing, in the beginning of your career, you should choose a company where you believe that you will get good work, right? So if you are able to do some internship in some startup, that is the very best, because you get exposed to so many different things, right? Back end, there are so little amount of people working in startups, and a lot of responsibilities are given to just small number of people, so you get a lot of work. Okay, so even though you are planning to go to companies like Google and Microsoft, which are well established already, you won't find as complex work. I mean, in some areas, yes, you'll find, but mostly in general, not as complex as you'll find in startups. You will get a lot of work, right? So just make sure you do some internships also before you move on there. And yes, computer programming is the way to go, because no matter which company you go for, right? For each company's interview, you have to go through DSA rounds. In Google itself, we have like 4 or 5 DSA rounds. So in each round of 45 minutes and one question is asked. So yeah, DSA is a good way to go, right? Now, a question from Complex. I'm having trouble grasping, not getting intuition, new problems that are related to greedy algorithms. This is literally the worst part of it. See, for other algorithms, you get certain idea that how to solve it. You see some observation, you make some observation, and you are like, yeah, I'll be able to solve it using DP or graph algorithms. I need to apply HLD or things like that. But in greedy, it is very difficult, and it's not just your observation. I have faced the same issue, and I was going through an article on code forces, that how to improve on greedy algorithm, because I was facing the same issue. So the guy who was, I think, red coder explained that for greedy algorithms, unfortunately, you have to practice a lot, different kind of problem, not some same type of problem, different types of problems for greedy algorithms, so that you get a majority of idea that how these are implemented. Once So basically, the way to improve is to practice as many problems as you can. If I could found that article, right, of that rat coder who has explained how to improvise in greedy algorithm, I'll put it in the description. I'll try my best to find it again. Okay. So the thing is, unfortunately, for greedy algorithms, you need to practice as many different kinds of problem as possible, right? And target at least medium level questions. That's the only way I know. And final question from Vishal. Any advice for me? Sir, I'm in CP for newbie, of course. I'm in the fourth year right now. Please, sir, if you could see, if you are a newbie, you are just getting started with competitive programming, just focus on three things. Right, basic algorithms like prefix sums and binary search. Right, I have a separate course for that, but separate playlist for that. Things like that. Second thing, number theory used in so many places, and third thing is bit manipulation. Once you have learned these algorithms, practice, of course, question of them, then you can move on to a bit complex algorithms like graph algorithm and string algorithms. All right. So four concepts are there which are used everywhere: graph algorithms, string algorithms, number theory, and dynamic programming. So you have to go through all of these. Right. Start with number theory, right, and bit manipulation. Once you are good with them, you can go ahead with the string or graph. Make sure before starting graph theory that you are good with recursion, because there are so many algorithms that you will be able to implement using recursion. And if you are good with recursion, you are comfortable with them, you'll find DFS and other algorithm that rely on recursion. You'll find those algorithms very easy. So again, start with the basic algorithm. You have to learn DSA. Start with the basic algorithms like number theory and bit manipulation. Then move your way through let's say string algorithm, and then to graph algorithms, right? Okay, two more question we'll take, and then we can close it. So again, from complex, that currently I'm in third year, I have good understanding in DSA and can solve questions and can solve the question. I have even done full stack. Should I do CP as well? See, if complex, if you are getting time, right, you should do CP. Okay, you should, because it will give you an idea. It will prepare you for the situation where you are given, where you are sitting in an interview, and the interviewer tells you a problem, and then tells you that you have got 40 or 45 minutes to solve it, right? When you do competitive programming, your mind practices in a way to solve problem in a given time limit, right? And that is very, very helpful. Not only that, you learn different ways to solve problems and apply the algorithms or DSA that you have just learned in different ways. Believe me, it will always amaze you. The problem that you will be solving in code forces context, it will always amaze you that, oh, I can utilize BFS or binary search in this way also. Right, so just go ahead with that. So Siddhi Saha, apologies if I'm pronouncing your name wrong. All right. So Saha asks, can you suggest good resources and problem set for flows? Okay. When it comes to resources, you can go for cpalgorithms.com, right? It's not like for each resources. I'll ask you to go to my channel, go through the playlist itself. But I believe that cpalgorithm.com have got good resources for flows. When it comes to problem set, you can always go for code forces. They have, I think they already have a tag for flows, so you can just use the tag and just go through the problem set available on code forces. All right. So for resource, cbalgorithms.com. For problem set, code forces. And for last thing from complex, thank you for the advice. I don't get much time due to college attendance, but I'm sure that I manage the time and do the. I'm a bit. See, for my college, what I did was that I mean, different people have different priorities. I never thought about getting a good grades in college. So for college time, I used to do something like this. Hardly I would go to college 2 to 3 times a week. The rest of the time, I would spend home doing competitive programming. But again, this is different for different people. It depends on your priority, right? So for me, competitive programming was very interesting. So I started doing that instead of going to college. and I was able to get a good CGPA, like 7.2 is something, 7.1 or 7, right? So yeah, if you get time, just make sure that you participate in contests on code forces or any platform that you like, but just participate in contests. That way you will practice, or you'll be training your mind to solve problems in given time limit, right? All right, guys, thanks everyone for joining. Hopefully this session was uh you know this session was helpful to you or to anybody. Now, in the next session, of course, we'll take a bit complex concepts. All right. And these practice problems that you see on your screens, I expect every one of you to be able to solve this problem. All right. So we can stop here. So thanks everyone for joining. Let's meet again in the next lecture. And till the next lecture drops, keep coding. Thank you.